Goals of physics is to be able to predict the motion of various objects. In this video, we're going to look at how the speed equation can be used to make those predictions. This problem deals with distance, time, and asks for speed. You may be able to answer this question just by logically thinking through the information, but I want to show you a strategy that can be used for many different problems and something that we'll use all year. The first thing I'm going to do is to think about what types of variables, what types of quantities are in this problem. And I can see that the types of problems, the types of variables are, of course, what we've been talking about: distance, times, and speeds. I'm going to use this chart to organize the information. I'm going to circle some key values like 400 meters. That is certainly the distance that the car travels. It's what the problem says, but also it's measured in meters. And so that allows us to determine what type of number that is, that label of the units. So we'll label that as D. And then we've got 10 seconds. That's going to be our time. Again, the units help me really identify those variables. And I can see that I know distance, I know time. Our speed formula is just set up to be used for this sort of situation because it tells us how to calculate speeds. We take the distance number, the 400 meters, and we put that on the top of the fraction. We put the time, 10 seconds, down on the bottom where the t is, and then we just do the math that's in front of us. 400 divided by 10 is 40, and the units we just state as meters per second. We combine that into a single unit. So in this second question, we have another car. Again, a speed is being asked for. We're given a distance and a time, and so this is going to be a very similar situation. Let's just go through the process one more time. We can organize our information by thinking about distance, time, and velocity or speed. We can recognize that the distance is the 100 meters, looking for those units. The time is 4 seconds. And so when we enter these values into the speed equation, putting the 100 meters on top for the D and the 4 seconds on the bottom for T, we just do the math that's in front of us. 100 over 4 is 25, and then our units are meters per second. Notice how sometimes we use SEC for seconds, sometimes we just use S. They're both very commonly used, which is why we included both in this video. Now in this third question, you might think, oh, it's about the same thing, except there's something very different here. A dog is running at 8 meters per second. So the 8 meters per second is already the speed. We've been given the value of speed. So this is going to have to be done a little bit differently. We are looking for how far the dog travels. We are looking for D. So the 8 meters per second is our value of V, the speed or the velocity. The dog's is keeping up the speed for 5 seconds, so that's the time, t. And so we would like to be able to use that speed equation. It's got all the right variables in it, but this does not tell us how to find d, it tells us how to find v. Let's do a little work on the equation itself. We're going to do a trick from algebra where if we want to get rid of a fraction, we can multiply both sides of the equation by what's in the denominator. So I'm going to multiply both sides by t, and on the right-hand side, the t's cancel out. And then we can write this a little bit differently. The d is now by itself, and on the other side, the v is being multiplied by the t. So this gives us the rule, the pattern of what to do with the velocity or speed value and the time. We're going to multiply them. So we'll put those values in to this equation. We can see what the numbers are telling me to do is to multiply the 8 times the 5. So that's going to give us 40. And then notice how the seconds were on the bottom of a fraction for the 8, but they're on the top for the 5. And so the units of seconds cancels out, and we are left with meters like we would expect for a distance. This problem has a similar pattern to it. We are given the velocity or the speed, 3 meters per second, that the elevator takes to travel from the first floor to the top floor. And we're given the time of 40 seconds, asked to find the distance. So this would be similar. Again, we would play with that equation a little bit until the d is by itself, and we would end up with d is equal to v times t. Then when we enter in our values of 3 meters per second times 40 seconds, the seconds cancel out. That helps us recognize that we've done the problem correctly, and we just do the math that we see. 3 times 40 is 120 meters. This last question is a little trickier. I put a star by it so we would recognize that. Can you see why this problem is different from the others? So let's get ourselves started here, and then we'll see what's happening. We'll get ourselves organized. The girl is riding her bicycle for 10 minutes, so that's going to be our time. And her speed is 5 meters per second. That's our v. So this is similar to the last two questions where we're looking for distance. And so we would rearrange our equation and get it into the form where it's d equals v times t. But the problem is that if we tried to put our numbers in right now, the seconds and the minutes from the time would not cancel out. They're not the same type of unit. And so we're going to have to make a change. We're going to change the 10 minutes into how many seconds that's equivalent or equal to. Remember that 1 minute is equal to 60 seconds. And so if 1 minute is 60 seconds, 10 minutes would be 10 times 60 seconds, or 600. So maybe we might want to change that in our organization as well to make sure that when we put our numbers into the equation, we put the correct value of time so that the seconds will cancel out and give us just meters for our answer. And then again, we just do the math that's in front of us. 5 times 600 is 3,000. By the way, don't worry if you need to grab a calculator at any point. That is always going to be allowed. You're always going to be permitted to use a calculator when you're doing any sort of calculation in our class.